Why does he record?
I record, okay? Yeah, so I will post on the YouTube. So yeah, if you have any further questions, you can go check the video after that.
Yay!
Yeah, great.
Thank you.
Okay, sure, you'll come. Sam. Yeah, Jonathan, let's start. And Sam, let's start. Okay, so this today, I know you guys already familiar with the Vieta theorem. For example, I just want to use this problem as an example. Okay, so this is one of the problem is x cubed minus x squared plus x minus 2 equal to 0, right? So my question is here, if I change this problem a little bit, okay? If the PQR is the roots of if the PQR is the roots of the equation 1, my question is how are you going to calculating 1 over P plus 1 over Q plus 1 over R?
Write it as a single fraction.
Write it as a what? Can
Single
you
fraction.
how to do that? How to do that? Can you show me?
PQ plus PR plus QR over PQR.
Okay, so you guys can write PQR and I can write sigma PQ, right?
It's just one.
Basically, it's a cyclic summation of the
Some
two
folks just
product.
use the sum like, I think.
Excuse me? Yes.
Some folks just use that.
Yeah, yeah, yeah. Okay. Oh, great. Oh, so we can write as a cyclic, right? PQ. Okay. So we can write in this way. Yeah, that's good. So for this one, right? So this is the first way to use the Vieta. So what you know is the sum of all the roots, right? Equal to, because I mean each term has only one roots, right? So that's why it's the power of one, because each one has the one roots, right? Then this one will be the an minus 1 over an, right? And the sum of the P and the Q of the cyclic, right? Each one have the two roots, so that's why it's the power of the 2, then an minus 2 over an, right? So basically for this one, we know the sum of the P, the sum of the PQ, and the PQR, right? Basically, we can solve this one, and we know this one, we can apply here. That's the solution 1. Okay, so the second one, how to use it? Okay, you can think about it. Let's think. Okay, is that if I say y equals 1 over x, right? So you think. Okay, so if the x cube minus x squared plus x minus
What
2,
are you doing?
I'm saying if this one can be write as x minus p, right? X minus q, right?
Are you making an expression whose roots are the reciprocals?
Yes. So I'm trying to see, okay, if I can I have a gy, right? Whose roots, the y's roots is 1 over p, 1 over q, and 1 over r, right? If I can find the g of the y, right? If we can find the g of the y, we can calculating the cyclic of this one directly, right? Okay, so now let's see what happens. Okay, so you think, so if y equals 1 over x, right? So that means if p is the root of x, the polynomial of the x, right? Then you can see 1 over p is the root of the polynomial of the y, right? So now let's see what we can do. So we can have x equal 1 over y, right? So now let's, because I mean this is the any roots for the y the reciprocal will be the roots for the x, right? Let's apply this one here. We know x is 1 over y, right? So then we apply here, it will be 1 over y of the cube minus 1 over y of the square plus 1 over y minus 2 equals 0, right? So we're converting, we know, I mean, if any roots of here, for example, p is the roots of here, then you know 1 over p is the roots of the gy. So that's why what we can do is let's reorganize this, okay? By times the y cube on both sides, that will be 1 over square plus 1 over y minus 2 equals 0, right? We can change the sign to plus, negative plus. Then it will be 2y cubed, then minus the y squared, then plus the y, then minus 1 equals to 0, right? So now you know for the y, right? If because p, q, r is the roots of this one, so now you know the 1 over p, 1 over q, and the 1 over r is the roots of this one. So then you can directly get this one. This one is only a single roots, right? So negative 1 power to the what? Jonathan or Sam? Power to the
First.
every term has how many roots?
1.
1 roots, power to the 1, right? Then negative 1 over 2, right? So the answer is
Half.
half. Okay, so this is the second way to do it. Okay, but for the inverse, we don't have to do that, right? Because if you know, as what we see, if you know the sigma p and sigma pq cyclic, and you can directly apply into this equation, right? You don't have to do that. But for some problem, if we use the second solution, this is the solution 2. Okay, it will be much more simpler. Okay, so the first thing I want to talk about, the first problem, okay, is this problem. I think it's in the Mr. Sword homework, and also it's the AOPS intermediate algebra problems. Okay, so it's the intermediate algebra problem. It's the 20.83. Okay, so let's see this problem. So for this problem, if you write as this, okay, so let's read the problem first. Okay, so px is a degree of the fifth degree of the fifth polynomial, and it has 5 roots. And the qx is the x squared minus 2, right? So we want to determine the product of the qx. Okay, so if you think if we directly applied it, so we basically we know sigma ri, right? We can do the sigma ri rj, the sigma cyclic, right? And the 3 of them, and the 4 of them, and the 5 of them. Okay, but take a look at this. Is the r1 squared minus 2 times r2 squared minus 2 times r3 squared minus 2, and if you multiply them together, is that too complicated?
Squared minus 2 times this.
Okay, so from here you can get the square, right? Is that what you mean, Tim? Sam?
Yeah.
Okay.
I think we just set the roots, like y equal x squared minus 2.
Yes. So
Like the
now, I mean, if we directly try to solve it, it's a little bit complicated, right? So let's using solution 2. So the solution 2 is we want to find a function of the y, right? Okay, so we expected, because I mean, we expected to be degree of what? Degree of the gy we expect to be what? Think about it.
y is like when you plug in y equal x squared minus 2 in, right?
Yes.
So shouldn't it be 10?
Jonathan, what do you think? What do we expect it about the g of the y? The degree. Okay, let me clarify a little bit. I want to have a function of the gy, okay, whose roots, the roots of the gy, okay, is the r1 square minus 2, r2 square minus 2, to r5 square minus 2. So what's the degree of the function of the g of the y?
10.
I don't think it's 10.
Okay, if you think if it is 10, if let's see, if g of the y something is
Actually,
the
5,
10,
I
right?
think.
Is the roots of the 10, it should have how many roots? No matter
Five.
complex or the real.
Since these are the roots.
That would be 10 roots, right? Or equal roots together, right? But this one have the 5 roots, right? These are the 5 roots belong to the px.
So still there's degree 5.
Yes, we expect it to be 5, right? Okay, now this is the first step. Now let's do the second step thinking, okay? So let's do q of the x is equal to y is equal to x squared minus 2, right? Based on the concept is we trying to find what? We are trying to find x equal, right? Something of the y. Yes, so x squared equal y plus 2, right? So we want to somehow substituting back using this one, right? Applied back into the p of the x.
You can quickly remove the x squared and replace it with y plus 2.
We can kind of want to substituting back into this one, right? Into this equation. Okay, so you can see the even power is no problem, right? The very annoying part is this all power, the x to the fifth, right? Yes. So what are we going to deal with this? Let's do this. So you can see, okay, great. So you can see we have the x to the fifth, right? Equal to negative of the x squared plus 1. Jonathan, do you understand this step?
Yeah.
Okay, now you think, because I mean we want to replace with the even power of the x, right? But we have the odd power here. How are we going to deal with it?
Do the best you can. Just
How,
plug in x to the fourth and then leave x.
yes, can we square it
Oh, we can also square
to
it.
make it even?
Yeah.
Okay, then we can do x squared plus 1 over the square, right? Now we can replace, see, this one,
even.
x squared to the fifth power equal to the x squared plus 1 to the square, right? And then you replace becomes the y plus 2 of the fifth power equal to the y plus 3 of the square, right? Jonathan, you understand this step?
Yeah, but I feel like this lecture is going too fast.
It's too fast to you? Which step you don't understand so far?
I understand it.
You understand it, right? The goal is trying to remove the fifth, and you can see what's the degree of the g of the y of this equation.
5.
The degree is 5, right? G of the y equal to 5. That's very great. That means we find the polynomial equation of the g of the y.
Wait, now we just need negative 1 to the 5 times the
Yeah, whose roots are what? is the R1 square minus 2, R2 square minus 2 to R5 square minus 2 are roots of this? Are
Yeah.
roots of this one?
Yeah.
Okay, now it asks us to solve what? The product of the 5 roots, right? This one equals basically negative 1 power to the what? How many terms in each of in this product?
There's only one. No, there's 5.
5 terms, right? Yes. Then we need to be using the A0 over the A to the
Which is
5,
just
right?
0.
Right. So now let's see. After expanding this, right? So what is the A0? A0 is 2 to the 5 on the left side and 3 to the 2 on the right side. Then we subtract, right?
So we have 32 minus
So
9 or 16.
yeah, so A0 is 23, right? That
Oh no, 32 minus
A5
9
is 1, right? So we don't have to expand this. We only need to take the whatever the term we want, right? So over 1 is negative 23. So what I want to say is normally use the variable, I mean the you know,
A variable replacement.
the variable replacement can be much simpler, make the problem much simpler. We try to, instead of directly using the relationship between the sigma of all the roots of all the Vieta and see the relationship between the between the given Vieta variables against those functions of the new function to of the new roots, right, to the new polynomial. Instead of doing that way, we try to find the new polynomial, okay, a new polynomial with another function that whose roots is the one you wish to get, okay, the R1 square minus 2, R2 square minus 2 up to R5 square minus 2. Okay, so this is the one way how we can simplify the problem. So any questions on this problem?
No.
Okay, great. Okay, now let's move on to this one. Okay, so Sam, have you ever the teacher talk about faster way to solve it?
Oh no.
No. Okay, so let's try my approach. Okay, this is the the simplest way I can do. Okay, so let's see this. So the A, B, C are the distinct solutions to this one, right? Maybe if you are lucky, you try to solve one of the solution and get the other one, okay? But here I don't bother to solve them at this time, okay? Let's do it. So what we have, right? Basically I am trying to do is to get the to see what kind of polynomial have this kind of roots. Okay, so now let's write some basic things. Okay, so who can tell me what's the cyclic of the A, sum of the A?
2.
Negative
2.
power to the
1.
The
1.
first, then
Negative
times
2 is
negative
2.
2 of 2.
Okay,
3.
cyclic of the 2,
3.
3,
4.
4. Okay, now let's work on this part. Okay, so first, because Sam and Jonathan, okay, if I find the roots,
Find the root. What?
if I can find the roots of the after strip of this inverse, if I can find a polynomial of the g of the y with all these roots, I can also solve the problem, right? Once I know this roots is g of the y, basically the final step is to replace 1 over y, right?
Yeah.
Did you get it?
Yeah.
Because we are very familiar with the relationship of the inverse of that, right? Okay, let's see what's going on here. So did you see the b squared plus c squared minus a squared something here? And we know this one. So the first step, what's the first step we want to know? Did you see the symmetry is the b squared plus c squared plus a squared minus 2a squared? This is the c squared plus a squared plus b squared minus
So we
2b
know what
squared.
b squared plus c squared plus a squared is.
This is what we know, right? And
Yeah, so
then
we just plug it in.
yes, we remove the three variable here into a single variable of the a first.
And then we know what to do.
Okay, now first, how do we calculate in the sigma a square?
We just square this
Yes,
equation minus 2 times this.
good. Sigma a squared minus the 2 sigma ab. Okay, this is negative 2. What does this one? Oh, the sum of the square is negative 2. It must be what roots?
Imaginary.
It must be one real, two complex. Do you agree
Yeah.
with me?
Then we
Yeah.
use the formula.
Otherwise, you cannot get the negative ones, right? Basically, we can change this one. Oh, then we have to let's finish this one. Then we log back in. Okay.
Wait, what are you doing? What are you going to do after the variable replacement of y is equal to ab squared plus c squared minus a squared?
Okay, let's see it. Okay, so the a of this one, right? The a times the b squared plus c squared minus a squared, then it will be what? It will be negative 2, right? A,
Negative 2a
the
minus.
1 plus a squared, right?
Oh, yes, factor it.
Can we do this?
Negative 2a1 plus a squared?
Is that true?
Wait, why?
Hold on. This is the negative 2, right? So this is the negative 2. Right? Take out the negative 2. It's a times this one.
Yeah, you're correct.
There's 9 minutes left.
Yes, I know. Okay, but let's finish it. Okay, it's negative 2, right? Is a plus a cube, right? Okay, does a satisfy this one?
Why is ab squared plus c squared minus a squared equal to negative 2a1 plus a squared?
Did you see the sum of the a squared equal negative 2?
Yeah.
Can we use this? Is this one equal a times sum of the a squared minus a squared minus 2a squared?
Yeah.
Is this negative 2?
Yeah.
Do you understand now, Jonathan?
Yeah, did you factor out negative 2?
Yes, I factor out the negative 2.
Okay, what next?
Okay, the next step, right? I write as a plus the a cube, right? How are we going to deal with it? Just think about it. I say a satisfy this one, a cube minus 2a squared plus 3a minus 4 equals to 0. What I want to do is to reduce the power.
Yeah.
How we do it? We have the a cube equal 2a squared minus 3a plus 4. Can we apply backing?
Totally.
Okay.
And then go plug it back in the a equal a.
Then let's do it. Okay. It's you guys check my calculation. Okay, my calculation.
2a squared minus 2a plus
2a
4.
plus 4, right?
Yeah,
so I can take out another 2, right?
Why do you keep on taking out factors?
Because it looks better.
Yeah. Right? Okay. Now next step, if we write as this one, right? We finish one term, right?
Yeah.
Now let's see. Okay. Now the I call this term equal to A, right? So the A equals to the sigma, right, of 1 over A B squared plus C squared minus A squared, right? It's a cyclic. I can write as a cyclic sigma, right? I inverse of this is 1 over 4, right? And A squared minus A plus 2 of 1. Any questions? Is equal to 1 over 4, then sigma 1 over A squared plus A minus A plus 2. Any questions here?
Can you please erase the plus?
Yeah, let
Just
us
click plus minus.
let's erase it.
Erase what?
The erase this one. It's negative. Any is this right, Sam and Jonathan?
Yeah, I think so.
Okay. Now the common technique of this one. Okay.
I'm trying to understand this.
Okay. Trying to understand. Any questions? Sam, I think we need to log out. Then we log back in. Is that okay?
Of course.
Okay.
So, same meeting?
Yeah, let's do that. Let me.
Okay.
Yeah.
Do I leave?
Yes. We all leave. Then we.
Okay. Oh, he already left.
Yeah.
Hi.
Hello. Record.
Mm. Mm.
Wait, did you even record the last one? Hello? You're mute.
Oh, I'm sorry. Yeah, I talk about I'm on mute. So can you see my screens?
Are you recording?
Yes, I am. I continuously recording.
So how come it doesn't say it?
I use the other one the other way to recording.
Oh, you use OBS.
Yeah,
Oh. Okay.
What's OBS?
it's a
No,
recording too.
recording.
Yeah. So any questions about up to here?
No.
Nope.
Okay, now Jonathan, do you have any question? You said you want more time or something. Do you understand?
I understand now.
Okay, good. Now we are going to solve the B, right? Is 1 over the A squared minus A plus 2, right? So there is a common technique here. Okay, let's start. So we can solve the excuse me.
Never mind.
Okay, we can solve the two roots of this one, right? We can solve the two roots of this one. So if you try this, the discriminant, you will see discriminant less than 0, right? And these are all the integer
The
coefficients.
discriminant is -7.
Yeah, then they are the coefficients are integer. What does this mean? The two roots are a minus beta. What's the other one?
Conjugates.
A minus beta conjugate, right? So
Yes.
what we can do is we can splitting this as a coefficient of the C of A minus beta plus the A minus beta conjugate of the D. Okay. Now the next one is we trying to solve we try to solve what is C and D, right? The first, the A term, right? The A term, after you make a common denominator, make them times together, is the A term is that C plus D times A.
What?
Can you follow me?
A.
What are you saying?
I mean the power we have the power to the A term, right? After we make a common denominator.
Are you using butterfly?
Yeah, butterfly.
So we have AC plus AD, and then minus CB conjugate
Yes.
minus BD.
Yes, that's exactly what I mean. So we
Oh,
have this and we have this. Based on what we wish to know, here is 1, right? Is this equal to 0? And this equal to 1?
yeah, since we just, what's called again? I think, what's the method? Like the telescoping method?
So from this one, we know the coefficient C is negative D, right?
I think partitioning fractions.
Yeah, partition, yeah. This is the partition ways, right? So after solving this one, the beta will be what? Is 1 plus square root 7 of the I. Then the beta conjugate is
The 1 minus 1.
Right? So we know C is negative of the D, right? Now let's do this. So the D is equal to 1 over the beta conjugate minus beta, right?
Yeah.
And the C will be 1 over beta minus beta conjugate, right?
Yes. And then we can just plug it in. B, the conjugate of B minus B, I think is
what is the beta
7.
minus beta conjugate?
It's root 7 I.
Root 7I. So now we solve the C and D.
Yes.
Did you see it?
Yay.
Okay, now let's do them separately. So we call this term of the big X, and we call this term of the big Y, right?
We can split it.
Okay, now we split it into the sum. Did you see it? So we call this term of the C is let's see, C is the 1 over root 7I, right?
Yes.
Then the A minus beta, right?
Yep. And then we have the, I think.
Okay, think about it. We want to A is the root for this equation, right? Let's do the variable replacement. Okay, let's do y equal A. We can replace x A as x because A is the root of the f of the x, right? So x minus beta over 1, right? 1 over x beta x minus beta. Do you agree with me?
Yeah.
Okay.
Yes.
So what I did is
a new sheet of paper.
a new sheet of the paper. Oh, you need a new sheet of the paper. Oh, go grab it, Johnson. Johnson, did you get it?
Yeah.
Okay. So
Yes.
what I want to do is I want to do a 2-step here. Okay. the first step.
There's one step. Oh no, yeah, step
Yeah,
one.
the first step. The first step, I want to find a polynomial with the roots of this. Then the second step, if you want to do, or you either want to do, is you inverse it. Right? The second step will be trivial. Do you agree with me, Sam and Jonathan?
Yes, I do.
Right? This is 1 over x minus beta, right? It's why we want to find a polynomial of the g of the y with the coefficients of this, right? I mean, with its roots of the 1 over x minus beta. So I want to do 2 steps here to make it easy. So the first step, I want to find g of the y with the roots of the x minus beta. Then I can inverse it. Do you agree with me, Jonathan?
Yes.
Okay, for this one, we can see y plus beta equals x, right? So what can we do now? Very simple, right? It's x cubed minus 2x squared plus 3x minus 4. X cubed minus 2x
Wait, I
squared.
have one question.
Okay.
Why can't we just directly apply the method 2 for like if it can go up?
Okay.
Now for like this one here, why can't you directly apply method 2?
You mean we directly apply this one?
Yeah, apply method 2.
Method 2. Okay. You mean we inverse it. We try to find what is the a squared minus
Yeah,
a
polynomial.
plus 2.
Yeah, if we find a polynomial.
We find a
those roots.
polynomial at this as the roots, right?
Yeah.
Yeah, if you can find this, that would be great. I haven't thought about it yet. Let's see.
That's okay. Let's continue it your way. Then
Yeah, I mean, we need to think about it. I mean, yes, we can do this. But doing this way, it seems that you need to calculating this. You need to calculating what is the a squared minus a plus 2. This is simple, right?
yeah,
Then we need to calculating the product of the two, right?
not so simple.
My computer is bit glitch.
Is that better now, Jonathan? So this one is not so simple, right?
Yeah, I see.
Yes. So that's why I didn't use this way. Okay. Let me starting for still follow what I'm my approach so far. Okay. So Jonathan, for this one, right? We know the x satisfy this equation, right? So we want to find a y, right? Y as x minus beta as a solution to another equation, right? So what do we do here? We need to apply this one here. Do you agree with me? So we can do y plus beta of the cube. Is that of the x? Jonathan and Sam, did you see it?
Yeah, I'm trying to catch.
Yes, I see it.
Jonathan, you try to catch what? I can explain to you.
Trying to catch up.
Okay, where are you?
Line 1 over root 7 I sigma 1 over a minus beta.
This one? Are you here?
Yeah.
Okay. Do you need me to explain to you why this is the case?
Yeah.
Okay. Jonathan, we're starting from here. Do you agree with me? We are calculating with this.
Yeah.
Yeah, this part is a little confusing. Let me
Wrote that.
let me use this. Okay, Jonathan, do you understand this?
Yeah.
Okay, so what I mean is this one we can split in the denominator into the a minus its roots. I mean the beta is the roots of this polynomial of the
Beta
a.
and beta's conjugate.
Yeah, right. I have two roots. I have two roots, right? Then I can split in this term into a something over a minus beta and something over a minus beta conjugate. Do you understand now, Jonathan?
Yeah.
Then I can set up this equation. Did you see it? Because I mean
Why
here,
did we write Bitcoin?
hey, Jonathan, focus on what I'm telling you. Do you see the coefficients of the a is 0?
Yeah.
This one you can do butterfly, right? This is the constant. Do you agree with me?
Yeah. Wait,
So what do we have?
C plus D 0.
C is negative D, right?
Why is A C plus D 0?
Because do you have a terms here? It's 0 times a plus 1, right? Basically, this polynomial equal this polynomial. Did you see it? I mean,
Yeah.
this function equal this function of the a. They are identical. Jonathan, did you see it?
Yeah.
Do you really understand?
Not really.
Okay. Jonathan, take a look at this. Is this term equal to a minus beta?
Lying?
A minus beta conjugate, then C times the A minus beta conjugate plus D A minus beta. Jonathan, did you see this?
Yeah, the sidebar is blocking some of the writing.
Did you see it now?
Yeah, the sidebar is blocking some of the writing.
Okay, let me make it smaller. Did you see it?
Yeah.
Did you see it?
Uh,
So I want this one, right? I want this one equal this. Do you see it?
yeah.
Then what? C plus D of the A should be what? That should be 0.
Yeah.
This one should be 1.
Yeah.
Do you understand now, Jonathan?
Yeah.
Get it?
Yeah.
Then we can solve the C and D. Right? Can you follow now, Jonathan?
Yeah.
Okay.
I have a question.
So this is the C, right? This is the C, Jonathan. 1 over 7.
Samuel, stop crying. Stop.
Hey, Jonathan, will you focus on what I say, okay? Did you see it?
Yeah.
Do you understand? Do you understand how we get to this step?
Yeah.
Do you understand this step?
Yeah.
If you understand this step, then I want to do a two-step, right? Y over, basically I want to find the g of y with the roots of the 1 over x minus beta. I can find a g of the y with the roots of x minus beta first, right? Then you can inverse it, no matter how you want to do it or you don't, right? Then you know x is satisfied to this. Do you agree with me, Jonathan?
Yeah.
So how we can find the another polynomial of y that is with the roots of x minus beta? Do you replace x with this?
Yeah.
That's here. Can you follow now, Jonathan?
Yeah.
Okay, so it's y minus beta minus 4 equals 0, right?
Yeah. Minus 4 equals 0.
Okay, now let's expand it. So it's the
My
y
screen's
cubed.
a bit glitchy.
What?
My screen's a bit glitchy.
Is it better now?
Sometimes it pauses.
How about now?
It's working a little.
Okay. Did you see? We can expand it like this, right? That's the first term. What's the second term? Minus 2y squared, right?
Wait, so beta is a constant, right? So
Yeah.
is the
Beta is
variable.
constant, right? We
Okay,
solve the
got it.
beta here.
Oh,
It's just kind of confusing.
Yes. Beta is a root of this, right?
yeah.
Okay. So now it's minus 4 beta of the y, right? Plus 2 of the beta square, right? Then this is the 3 of the y plus the 3 beta minus 4. Do you agree with me?
Yeah.
Okay, now we know what? We know the x minus beta. Basically, it's what? It's a minus beta, b minus beta, and c minus beta satisfy are the roots of this equation. Do you agree with me?
Yeah.
Yep.
Okay, so it's y cubed plus 3 beta minus 2 of the y square plus 3 beta square minus 4 beta plus 3 of the y plus the beta cube plus 2 beta square plus 3 beta minus 4 equals 0, right? So now we find the polynomial with the roots of the what? Let me write here: a minus beta, b minus beta, c
And
minus
c minus
beta.
beta.
And
And
what?
now
But what do we want? We want to
reciprocal.
well, reciprocal, right? We want this a minus beta 1 over b minus beta and 1 over c minus beta. Okay, this is very easy, right? What can we do here? We can
We just
inverse this one, right? We can do 1 over y to the cube plus blah, blah, blah. Right? So what we want, which term we want? We want this term, right?
Yeah, since we want the sum.
I know this term and this term.
Yeah. Sorry.
Is that true? Yes. Okay,
Yeah.
so the sum of the a minus beta will become what? For example, it will be the p p0 p1 p2, right? So it will be, after we doing this, it will be the 1 plus the p2 of the y plus p1 of the y squared plus p0 of the y cube equals to 0.
So we want p1 over p0, negative
It's
p1 over p0.
negative over 1, right? Power to the 1, right?
Yeah.
And p of the 1 over p of the 0.
Yeah.
Jonathan,
Yeah.
can you follow? Do you
Yeah.
follow all this?
Yeah.
Do you follow up to here?
Yeah.
Any questions, let me know. Sam and
No.
Jonathan. I don't know whether Jonathan is followed yet or not. Any questions, Jonathan?
No.
Any
No
questions?
Nope.
Okay, now we can calculate in the p0, right? p0 is the beta cube plus the 2 beta square plus the 3 beta minus 4. Okay, and you know beta is equal to half of the 1 plus root 7. Root 7i. Now this one I remember is some negative 2.
We're supposed to expand that?
Yes.
Oh crap, I just get Wolfram Alpha out.
What let me see. What is this value? Uh, yeah, we need to expand it.
What?
Okay, here. Let me find. Okay, so we don't have to take time to calculate.
Samuel Lee, why you keep annotating random stuff?
Okay, so this is equal to the -2.
Why does Samuel Lee keep annotating random stuff?
Okay, so that's what we can get this, right? Okay, take a look at the second one. What is the second one? We have this term and this term, right? Let me write it down for you. Okay, so we have the 1/7 to the I. This is equal to the C. Then sigma 1/2 the A minus beta. We want to know plus D, right? D is 1/7 to the I of the negative. That's the D. Then 1/A minus beta of the conjugate. Right? So we want to do this,
Kind of glitchy.
right? So do we already solve this part?
Yeah.
Okay. So you can think about the other part. Okay. I show you something. Jonathan and Sam, pay attention to here. Okay. So here we have the sigma of the 1/7I of A minus beta, right? Plus this one is 1/-7I, right? A minus beta conjugate.
Yes.
Can I write this part into sigma of the 7I/1 of the conjugate over the A minus beta of the conjugate?
Yeah, the conjugate of an imaginary number without the real
Okay.
part.
So if this part is the x and this part is the y, is y equal to the x of the conjugate?
Yep.
Jonathan, do you understand this?
It's so bashy.
Let me show you. This is the part is C, right? This is the C over A minus beta, right? Jonathan? Sum together. Did you see it?
Yeah.
Okay, so C is 1/7I, right? A minus beta, right? Jonathan, did you see D? D is negative C. Did you see it, Jonathan?
Yeah.
Is 1/-7I, right?
Yeah.
A minus beta conjugate, right? Can I write this part as this?
Yeah.
Is this the conjugate? Is 1/7i's conjugate is negative? Is 1/7i negative? Negative 1/7i, root 7i. So this part is the y. Is y equal to the conjugate of the x? Jonathan?
Yeah.
Do you follow me?
Yeah.
Okay, here
Yes.
is x and y, right? Basically, we want to solve x and x plus y is equal to x plus x conjugate. What is x plus x conjugate?
X.
This is real part.
2 times the real part of what?
X.
X.
Did you
X
see it?
conjugate.
Okay, so we don't have to solve the second part, right? Did you see we already have this part?
Yeah.
Okay, now is equal to 2 times the real part of x. X is 1 over 7I times sigma 1 over a minus beta, right? And we have the 2 times
0.
real time 1 over 7 to the I, right? This one we know is the p of 0 over
Didn't we find that?
here, p1 over p of 0.
Oh no, we didn't find that yet.
Right?
Wait, won't it be 0?
Which one?
Since
So
P0,
complicated.
P1 over P0 is 0, and we're multiplying it by an imaginary
Yeah.
number.
Remember P1. Let's take a look at P1. P1 is not is a complex number here.
Oh.
Okay, so P1 is equal to 3
Oh,
beta
yeah.
squared minus 4 beta plus 3, right?
Is there any non-bachelor way?
Complicated.
Okay, so this number is equal to negative 4
Oops.
minus root 7I over 2.
Huh?
No. I mean, no. This number is 8 divided by this. Let me erase it.
Can you skip the bash part? I just solved it with Wolfram. Because I know how to do it.
Okay,
I think we all know how to do it.
Jonathan, you should know how to solve it, right?
Yeah.
Just apply it in, right? So this is
Yeah.
the root 7I, right?
We're gonna do Wolfram.
Yeah. So
Wolfram.
now you can do this one.
Wolfram.
Wolfram Alpha.
1 over 7I, root
Are you
7I,
allowed to use that?
negative, right? Now you can solve it, right? What I get is what? What I get is negative of the 1. Okay, so if you know how to solve it, now we already solved it. Okay, we know x and y.
Yeah.
Then basically we solve this problem, right? We already solved the b. Once you solve the b, you solve what? You solve the a.
No.
Right? So after this we solve the whole problem. That's how I solve this problem. Okay, so let's do the next one. Okay, so this one
Did you consider directly using method 2 and it turned out complex?
Which one, Jonathan?
Did you try directly using method 2 and it turned out to be complex?
Yes. So now let's go review this problem a little bit. Okay, this is so confusing, to a certain step. Okay, now let's review it. Let's review some key steps.
I feel like I'm already lost after line b equals 6 over a squared minus a plus 2.
Okay, so let's think about the first one. Okay, first one you can observe the denominator is b squared plus c squared minus a squared, right? Every denominator is kind of cyclic and contains of all the 3 variables. So what we do is we're trying to figure out what's the summation of all the squares and the minus 2a squared. So we can just only have a single variable on the denominator, right? On each term. That's the first step.
Computer is so slow.
Which is so slow?
My computer.
Oh, your computer is so slow. Can you see it now, Jonathan? Is your computer a little bit better?
It doesn't move very quick.
Okay, maybe you can ask mom to help you take a look. Okay, so the first step is we're doing this, right? Is we replace with a single variable, and the second one is because the a is the roots of this the cubic function, right? Cubic equation. So I want to reduce the order up to here. Okay. Then the next step is basically the question is ask us for the A. Right? The question is asked for us for the A. Then we see the A equal to negative 1 over 4 of summation of the times the B. Okay, so next step is we want to solve the B, right? Because once we solve the B, we solve the A. Okay, Jonathan, I address your problem a little bit, question one more time, okay?
Yeah, this is a bit difficult.
Okay, so did you see it's 1 over A squared minus A plus 2?
Yeah.
So basically we can, this quadratic have two roots. It's beta and beta conjugate, right? So basically we can do 1 over the A minus beta times A minus beta conjugate. We can splitting them into a C over 1 A minus beta plus a D over A minus beta conjugate, and the C and the D are constant, are coefficient. Do you agree with me here, Jonathan? You're getting lost here. C and D are constant, right?
Yeah.
So if C and D are constant, so what I can do is this, Jonathan. Did you see here? I can make them together. So A minus beta conjugate, C times A minus beta conjugate plus the D times A minus beta. So my denominator is wishing to I wish to have what? Equal what?
Do you call this a faster solution than using cubic?
Yes, because I mean we try the cubic. Based on Sam's suggestion, we try to find a polynomial with the roots of the a squared minus a plus 2. But we think after expanding, it's still very complicated. Okay, so that's why what I want to do in this way. Jonathan, did you see it? You understand this way, right? So now I want to be the numerator equals 1. So that means the coefficients to the a part is 0. Do you agree with me?
Yeah.
The coefficients of the constant part is a 1. That's this part. So now we can solve the coefficients is C equal negative D, and basically we can solve the two coefficients C and D. Get it, Jonathan? And Sam? I think Sam get it. How about you, Jonathan?
Yeah.
Do I address your problem here? Do you understand it now?
Yeah.
Jonathan?
Yeah.
Okay. Now you can see, okay? If you understand, see you understand, okay? Now we are trying to solve C over A minus beta, right? And C over B minus beta, C over...
I think we have 4 minutes left.
Yeah, I know. Okay, so we're trying to solve this one, right? Sigma of the A minus beta, C over that. So that's why what I'm showing you here is if the first summation is X, right? The second summation is the Y, right? But you know the coefficients of the first one is 1 over root 7i, and the coefficients to the second one is 1 over negative root 7i, right? Right? So the 1 over to the negative 7 root 7i is equal what, Jonathan? Is that equal to the 1 over 7i of the conjugate?
Yeah.
So what do I say? Is this the y equal the conjugate of first part? Do you understand this?
Rihanna is a bit noisy.
I know, but do you understand this now?
Yeah.
Okay, so if y is x conjugate, it means we only need to solve the one part. Am I right?
Yeah.
X plus y equal what? X plus the x conjugate is 2 times the real part of the x. Right? Get it?
Yeah.
Okay, then the next part is how we solve
We
the.
solve beta. Do we really just solve the problem after some calculation?
Yes. Once you solve the beta, and the next part is only, I don't go through the detailed calculation, but we need to solve this, right?
Yeah.
Okay. So we solve the x is we can find this, we can find we can find the roots, a polynomial of the roots a minus beta, b minus beta, c minus beta, right?
Yeah.
Okay. Okay, that's all what I want to review about this problem. And let's log back in. And I think the last 45 minutes we can finish all the problems. Great.
So this was the hardest?
Yeah, I think this is the hardest. What do you think? I think this is the hardest.
Yeah.
Really complicated.
Yeah.
Bashy.
Yeah, Bashi.
Hey,
Let's log
are you
back
recording?
in. Yes,
Are you
I'm
recording?
recording.
So I'm leaving again.
Yeah, let's leave again and come back.
Bye-bye.
Bye.
Bye.
Hi, Sam.
Hi,
Hi.
Mr.
Okay.
Yu.
Okay, Johnson is here. Hi, Johnson. Johnson, can you see my screen? Sam, can you see my screen? Hey, John.
Yes.
Yes. Okay. Hey, how about you, Johnson? You are on mute.
Yeah.
Okay. Now, if this is the now let's see this problem. Okay. So the the degree of the first of the let's notating as of f of the x, g of the x, and h of the x. Okay, for f of the x, we have the roots of the r1, r2 to r of the 2022, right? Then we have another set of the roots of the s1, s2 of the s2022 is the roots of the gx, right? And the last one is we have the t1, t2 of the t of the 2022 is the roots of the hx, right? So the question is ask us to solve, okay?
Are you recording?
Yes, I'm recording.
Oh, good.
Yeah. So the question is ask us to solve the Ri and Sj plus the sum of any orders of the Si of the Tj and
Sigma,
any
sigma.
order. Yeah, any order of the Ti of the Rj, right? Okay.
Split Vietas.
When you take a look at it, it must be
Metric. It's
Vietas,
rotation.
right? But we need to think about what kind of the polynomial of can give us the Ri, Sj.
Now I just
SITJ.
realized that I could have done this on my own.
Jonathan, what did you say?
I have an idea.
Now I just realized I could have done this on my own.
Okay, good. What's the idea?
I have an idea.
Mm-hmm.
Oh, I think I could just combine the summations.
Mm-hmm.
And then we have RISJ. Wait, and then, no, I'm not sure if that will work.
Mainly because sigma 1 less than or equal to ij less than or equal to 2022 rj sj.
Yeah, but then if you combine them, I'm not sure if
Products
they'll
of
work.
themselves.
Okay, so think about it. If you want the RISJ, SJ, SITJ, and TIRJ, does that mean I need to find a polynomial with the roots of the R1 to R2022 plus the roots of the S1 to S2022 plus the roots of the T1 to T2022? If I find a polynomial with this 6066 roots together, okay, so then I can find the you see,
I think I already got it.
if I have a polynomial of this, right? So what's the any of the product of two will contain these components, right? We'll have this as A. Do you agree with me?
Yeah.
Okay,
Yes.
let's see.
I think
665
I already got
x60
it.
65 plus the a60 64, then x60 64. So at least these coefficients, the a will be a part of these coefficients. Do you agree?
Yeah.
Do you agree, Jonathan and Sam?
Yeah.
Okay, so think about it. Then what it looks like. This function, this equation looks like fx times gx times hx. Then this will be the 66 roots of this one, of the capital Fx.
I think I already got it.
Get it? Okay, but think
already
about it.
got the answer.
Yeah, think about it. The A6064 contains, right? Contains ij of the RISJ, then ij of the SITJ, then contains
we
ij of the RJ, right?
There's a much faster way.
Plus what? Plus I minus j SISJ, right?
Yeah.
I minus j, I less than j
Wait.
is
This is equal, right? Like here. Is this equal here? Is that equal?
no. There's no this because you think okay. I can draw a picture. Okay.
I already got the answer.
Good. Can you listen? So we have so let's see our structure of the roots. Okay. So R1 to R2022, S1 to S2022, T1 to T2022, right? Because any two can be a pair, right? So basically what we have, the structure is any product between the one of the R against the one of the S, one of the R against the one of the T, one of the S and the one of the T, right? And the product between inside R and R, the product between inside S and S, and the product inside T and T. That's 6 terms. Did you see it here, Sam?
Yeah.
You see it here, right? So that's why here between the two ones, you cannot using I less than j because it is possible R1 as 2 and also possible R2 as 1.
Yeah. So
there is no order here, but here you have the order. Inside the R, it must be R1, R2, right?
There's a much faster way.
Okay, what's your ways, Jonathan?
So basically, yeah, it uses the fact that sigma 1 less than or equal to ij less than or equal to 2022 RISJ is equal to sigma 1 less than or equal to I less than or equal to 2022 RI times sigma 1 less than or equal to j less than or equal to 2022 SJ.
Okay, I see. So you mean we can basically sigma Sj, right?
This can easily be proved using some sort of rectangle diagram.
Oh yes, this is a faster way. Yes, this is the faster way than what I did. Did you see it, Sam?
Yeah.
Yeah. Johnson say we can take out the I as a constant, then sum of the j, then we sum of the I. That's it.
Yeah, I got it.
Yeah. But what I did is, I can be, the Vieta of the fx and the gx and the hx can give you this,
Yeah,
and
that's
we
like
can have this.
originally first.
Yeah, and we can solve it. Okay, good. Let's move on to maybe
Wait, can you go
almost.
back?
Yes. Oh, sure.
Can I use the bathroom?
Okay.
Wait, for this one, I was going to clarify something.
Okay.
Is there a comma here? Like, is this like a comma?
Where is it? Oh yes, there is a comma. I did.
Yeah.
Yeah. Should be a comma here.
Wait, so if it's a comma, are we counting these cases twice? No, but no, like,
No.
because we know,
Because it's different group.
so one is ij, but then the ij are different. No, like this one's I less than j, but isn't this one j greater than I?
Hold on. R1 S2, R2 S1, then R1 times S1.
Like, we know both cases are included here. In this case, I think is it included here? No, like, no, this case is
No.
included here.
No.
I'm confused.
So R1 S1 and we take S1 and we take R1 and S1. We take the R1 and the S2. So this one, yeah, this one is we were only counting once, right? When they are equal, we're only counting once.
Oh, so is this equal?
Yeah. So this is every pair, right?
Oh, so basically I equal j, so it's just simply r I s I.
Yeah.
Oh, that's what you mean. Oh, I get it.
Did you see it? For this one, we cannot count in the R1 times R1.
I thought you meant like, oh, we have RI and then like SJ, but then I and J can be anything. But yeah,
this one could be no problem because there is no equal roots, right? For this one, we need I less than J because we don't want the equal roots. Yes, we don't want the equal roots.
So we have this part is Vietas, and then this part is nothing.
Yeah, this part of Vietas you can from separate the function, right?
And that's what we also know, right? So it's like RI squared.
Yeah.
RISI, and then yeah, I think we also can find that.
Yeah. So this part is easy, right? It's separate. It's from the separate equations. Then this is yeah. You can make make a product and combine them together.
Yeah. Okay, got it.
Yeah. Okay. Let me see. Jonathan, are you ready? Okay. Now let's move on to this problem. Okay, so this one, right? So it's the same thing. It's a p cube plus q cube plus r cube, right? So what I see that we can do this. This is the solution one, right? Jonathan, do you understand this?
Yeah.
Does this one give you p cube, r cube, right?
Yeah.
Okay, let's do our variable replacement. Okay, let's do our solution 2. Let's try to see how this one works. Okay.
So solution 1 is just using that thing.
Yeah.
And solution 2 is variable replacement again.
Yeah. Yes.
I use solution 1.
Yeah. Okay. Yeah. Here is solution 1. Let's see
Samuel
how.
is writing out solution 1. That's what I use too.
Okay. So basically it's p cube q cube, right? We want to find a polynomial with the roots of this one, right? So we can do y equal x to the cube, right?
Can you scroll out?
Scroll up, okay. Like this.
Can you make it smaller?
How about this?
I think it's the smallest you could go.
Is that okay?
Yeah.
Okay. So basically, if we set this, right, we want to replace the x cube to be the y, right?
Yeah.
Okay. So now let's write it down. So x cube minus x squared plus x minus 2 equals 0, right?
Yeah.
So we can replace this one. We can replace to the y, right? But this and this is pretty annoying. Did you see it?
They're not multiples of 3.
Okay, now let's do it. And they are not multiple of 3, right? But what if I write like this, does it remind you what could be what could have this kind of term? What's this?
Oh, we can use the x plus 1 times x squared minus x plus 1.
Did you see it?
Yeah.
That's why what are we am I going to do this?
Yeah.
Okay, because this one gave me the cubic, so I'm easy to replacement. I know the x cubic is y, right? So what's the next? X cubed minus 1 equal x minus 1, right?
Yeah.
Then x cubic plus 1. I'm sorry, x plus
Why
1.
do you say cubic instead of cube?
A cube, right? Do you see it?
Yeah.
Then what do we have? Then we have x plus 1 equal, can we replace this one as y?
Yeah.
What's the next step?
We want to express x in terms of y.
Do we have this now?
Yeah.
Yeah.
Then what's the next step? We want a polynomial of y. We are very
Cube it.
We can cube there, right?
Yeah.
So, but cubic after cubic, now it's testing you guys too. Okay, this is the polynomial with degree of what?
4.
Degree of 4.
And we only want 3.
We only want 3. What happens here? Think about it.
I'll just go checking 2.
Okay.
We accidentally added a solution of 2.
For example, yes, if we have another, if we have another root of the alpha, right? For this one, for the g of y, we have 4 roots, right?
Yeah.
But alpha, I mean, but I'm sorry, the x equal, yeah. Y equal x cube, so x equal, okay, but this one is not a root
of
fx.
Yeah.
That means the g of the y can be written as a y minus alpha and a y cube something, right? So this part have the roots of the what? This part have the roots of the p cube, q cube,
so we're done.
and r cube. Then we are done, right?
Yes, I don't think we
Okay, now let's do it. So I expand it. If we expand this one, it will be the y of the, I'm sorry, here's 8. Okay, so it's the y to the fourth minus 3 to the y square to the cube plus 3y square, then minus y minus 8 equals 0, based on the rational root tested, right? So basically we can try to the 1 plus minus 1, 1 plus minus 2, 1 plus minus 4. Let's try 1 first, right? So plus minus 1 to the first one is 1, right? Then the next one is negative plus minus is the 3. Then the next is plus 3. Then the next is negative plus is 1. Then negative is 8 equals 0. So we can take 1 plus 3 plus 3
You're using
plus
RRT.
Yeah, is this 0?
Yeah.
So that means which one is the root?
2.
Plus 1 or negative 1? Think about it. We need to be plus 3.
Negative 1.
Negative 1. Now you can using the synthetic division, right? 1, negative 3, 3, then negative 1, then negative 8, right? And the negative 1 here. Then 1 is negative 1, negative 4, then it's a 4, then it's 7, then it's a negative 7, negative 8, it's 8 and 0. So now did you have a cubic equation now? With the first of the y plus 1 times this one, right? Y cubed plus something, blah, 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 equals 0. So the only thing we need to check is y equals negative 1. That means x equals to what? Remember, let's go think. Okay, don't forget. Y equal what? Y equal x cubed, right? What is x? X equal what? Do you understand, Jonathan?
Yeah.
Do you understand this?
Yes.
It's negative 1, right? Let's go check. Is negative 1 a root of this?
Yeah.
Negative 1 minus 1 minus 1 minus 2.
Definitely not.
If it not, means what? Means that the PQR are what? Are here, right?
Yeah, they changed it to negative 1, so we're done.
Then are we done?
Yes.
P cube, Q cube, R cube are the roots of this one. Then we are done.
Yeah.
That's here.
Yeah.
Okay, so what I'm telling you is sometimes maybe the verbal substitution is not fast, but in some way, in some complicated problems, when you see the Vieta problem, the substitution is more powerful.
Are we leaving?
Yes, this is the last one.
Oh.
Okay, so this one, you have the 3, right? Think about it. How are we going to do this? The standard format, y equal 3x minus 2. Then what? Y cube plus 2 equal...
We don't need to do this.
Yeah, we don't have to, right?
We can just do this. We can just say, we already know what 3 or 1.
Yeah. I know we can do that. Take a look at this. I'm doing the same thing.
Board.
This. Right? Right, Jonathan? And Sam?
Yes.
Yes, right? So you can think Now it's you can just think 3x minus 2. Is that here? Equal this, right? So that means this one of what? So root 3x minus 2 is equal to x minus 1. Then variable change. It's r1 minus 1 plus r2 minus 1 plus r3 minus 1. See it? Jonathan, did you see it?
Yep.
Okay, but what I mean, what if we don't have this one? Okay, well, what if you cannot you cannot just have this one? Okay, what I mean is how do we find a polynomial? Okay, of the y can let us to do the verbal replacement like this. So what I'm doing here is x minus 1 to the cubic minus 3 of the x minus 1 then plus 1 equals 0. Okay, so now we can do the verbal replacement of we can replace the x. So we can replace do the verbal replacement.
What does that say? Pi, be real. I, be irrational. E, why don't you all join me and become negative 1?
3 minus 3, right? It's a minus 1.
Yeah. Basically, it's just the same thing as the previous one, right? We just set it y, and then we just manipulate it, and then we just use the variable replacement.
Yes.
Just we know that x equal. Yeah, I get it.
Yeah.
Plug it back.
So after calculating this, we have the y cube equals the 3 of the y cube plus 1 of the cubic function, right? Because basically we know the r1, r2, r3, right? What we want to have a degree of the g of the y as what? What is our goal? We know 3 roots, right? We also want to find another 3 roots to be roots of the equation of the g of the y, right? So what's the degree of the g of the y?
The degree of g.
Again, we have the r1, r2, r3 is the roots of this
3.
system, right?
3.
We want to have a g of y with the 3 roots of 3r1 minus 1 cube. How many roots have we want?
3.
3 roots. So we want to g of y with the roots. How many roots?
3.
3. So we want a degree of 3. That's why all this manipulation is trying to get a degree of 3. So you can see this is the power to the 3. So we have power to the 9. So that's why we finally get this, and we can take the cubic roots and get us the the g of the y with the degree of 3.
Minus 3y plus 1.
Yes. Once we have the 3, then we are done. So that's about all of the problems here. Okay, so I think this problem is most confusing, this part.
Yeah,
And
that's difficult.
yeah, but this one is what I tell you is, and this problem is interesting to let you think more, or think about it. Is what if we have the what if we have the we want 3 roots, we want only 3 roots, right?
Yeah.
But we have a polynomial of degree of the 4, so we need to check one of them is not belong to the original equations, right? So we become the polynomial of 4, but we want 3, so we introduce one more roots, and this one is not in the fx, so the rest of them are in the fx. So that's pqr. Here is the p cube, q cube, r cube. Right? Any questions?
Nope.
Okay, great. If no
Yeah,
questions,
I really like the substitution part. It's pretty fun.
yeah, thank you. Yeah, if no questions, I think that's about it, right? And I have a good night. And you get up, you wake up very early, Sam. And have a good night to you, your brother, and your mom.
谢谢，谢谢魏叔叔。魏叔叔，拜拜。
Bye.
Bye.
拜拜，我叫拜拜。
Yeah, bye. Yeah,
Have a good night.
have a good night. Bye bye.
晚安，宝贝。